Okay, so today what we're going to be doing is adding and subtracting radical expressions, and I will tell you, I do not think this is too difficult because here's the reality of adding and subtracting radical expressions. It works just like adding and subtracting like terms. You can only add and subtract radicals that are the same. So, as an example, I've got square root of 2 plus 3 square roots of 2 gives me 4 square roots of 2. And this is just like x plus 3x gives me 4x. They're like radicals, so I can combine them. The radical doesn't change. It still stays the square root of 2. So would you agree that's probably not too difficult? Check out this one. Cube root of 7 minus 5 cube roots of 7 gives you negative 4 cube roots of 7, because you have one of them minus 5 of them gives you negative 4 of them. Here's an example with variables. Square root of 5xy plus 8 square roots of 5xy. Here's 1 plus 8 gives you 9 square roots of 5xy. So you see how you can only add like radicals. So here's an example just to show you. If you have square root of 3 plus the square root of 5, you cannot simplify this. This is simplified. All right, you cannot simplify this. So let's go down here to our first example. So I've got 3 square roots of 5x minus 2 square roots of 5x. Just subtract your coefficient. So 3 minus 2 gives you 1. That would be 1 square root of 5x. Now, if you go to example B, 6x squared square root of 7 plus 4x square root of 5, are those like radicals?
No.
No. So you cannot simplify. You cannot combine these. They are not like radicals. So let's go to the next example. Example C. 12 cube roots of 7xy minus 8 fifth roots of 7xy. Are those like radicals? No, because this one's a cube root and this one is a fifth root. Those are not like radicals. You cannot combine. So we're just going to write cannot combine. And our last example, example D, I've got 3x square root of xy plus 4x square root of xy. Are those like radicals? Yes, they are like radicals. So we can add their coefficients. What's 3x plus 4x? 7x. So 7x square root of xy. Let's turn to the next page. So if you look at example 3, part A, these don't look like radicals, do they? They don't. So you can't combine them as they are. However, would you agree they might be able to be simplified? And once simplified, maybe we will have some like radicals. So that's what we're going to do. We're going to see if we can simplify. So first of all, how can I split out square root of 12? And if you don't have this handy, get this handy that tells you what numbers you can use. So how can we split 12? 4 and 3. So square root of 4 and square root of 3. How can we split 75?
25 and 5.
25 and 3. I like that. All right, so square root of 25. Square root of 3. So here's what happens. Square root of 4 is 2. Square root of 25 is 5. This gives us 2 square roots of 3 plus 5 square roots of 3 minus the square root of 3. And you're going to combine your like radicals. 2 plus 5 gives you 7. 7 minus 1 gives you 6 square roots of 3. So you've always got to make sure that all of your individual radicals are simplified before determining that you can or can't combine them. So if we go over here to example B, this is a cube root. All right, we're going to need this card up here to show our cube roots. How can I split up 250? Remember, I need to use these numbers right here, 1, 8, 27, 64, and 25. Yes, so cube root of 125 and cube root of 2. What about 54? How can I split 54 up?
2 and 27.
2 and 27. So I'm going to write cube root 27, cube root 2. And how can I split up 16?
4 and 4. 8 and 2.
8 and 2. Because remember, you've got to use only these numbers.
Oh, yeah.
All right? So cube root of 8, cube root of 2. So let's get the red pen out here. Cube root of 125 is 5. Cube root of 27 is 3. And cube root of 8 is 2. So this gives me 5 cube roots of 2 plus 3 cube roots of 2 minus 2 cube roots of 2. And now I do have like radicals. So 5 plus 3 is 8. 8 minus 2 gives me 6 cube roots of 2. All right. The next thing we're going to do is we are going to use FOIL on some binomials that contain radicals. So you see right here, you've got two binomials. They contain radicals, and we're just going to FOIL them. And we're going to FOIL the same way I know you all know how to FOIL. So first is 4 times 5 gives us 20. My outers, the 4 times 4 gives me 16 square roots of 2. Agree? 16 square roots of 2. My inners, 5 times 2 gives me 10 square roots of 2. Now, when I do my last, I have 4 times 2 is 8. And square root of 2 times square root of 2 is square root of 4, right? So you're going to multiply the outsides together and the insides together, but square root of 4 is 2. So here's what I really have. I have 16 square roots of 2 and 10 square roots of 2, and that's going to give me 26 square roots of 2. But now I've got to combine my terms that are constants. This is 8 times 2, which is 16. 16 plus 20 is 36. So this is going to give me 36 plus 26 square roots of 2. So see how that simplifies very nicely. And it doesn't give you a trinomial, but only a binomial. So what I want to show you is a really neat trick. Notice when we do this one, actually this isn't the neat trick, this will be the neat trick. Let's just go ahead and see how this one comes out. I've got 3 times 5 for my first equals what, 15? 3 times the square root of 7 is plus 3 square roots of 7. Negative square root of 7 times 5 gives us minus 5 square roots of 7. And negative square root of 7 times positive square root of 7 gives us minus the square root of 49. Now, if we go in here, square root of 49 is 7, right? So 15 minus 7 gives us 8. And I've got 3 square roots of 7 minus 5 square roots of 7 gives us minus 2 square roots of 7. All right, this is the cool one. Notice here, this binomial and this binomial contain the same numbers, right? But one is plus and one is minus. Remember, those are called conjugates. Remember from when we were doing imaginary numbers? Those are called conjugates. The coolest thing happens when we multiply radical binomials that are conjugates. So watch what ends up happening. So I've got 5 times 5 is 25. My outers, 5 times the square root of 7 is plus 5 square roots of 7. My inners, negative 7 times the square root of 5, or negative square root of 7 times 5 is minus 5 square roots of 7. And negative square root of 7 times positive square root of 7 is minus square root of 49. Now the square root of 49 is 7. But look, I've got positive 5 square roots of 7 and negative 5 square roots of 7. They cancel. So this whole thing is 25 minus 7, which equals 18. And I do not have any more radicals. So this is a great way to get rid of radicals, and that is to multiply binomials that are conjugates. They have the same numbers, one's plus, one's minus. One more example of that right here. 6 times 6 gives us 36. My outers, minus 6 square roots of 12. My inners, plus 6 square roots of 12. And my last, square root of 12 times negative square root of 12 is minus square root of 144. Come on over here, cross it out, and write in 12. Notice that my inners and my outers are going to cancel each other out. And all I have is 36 minus 12, which gives me 24. So, if we go down to the bottom of the page, we are going to rationalize denominators. Now, you have already done this method before when you had imaginary numbers in your denominator that you were trying to rationalize. All right? And remember, when we had a binomial in the denominator with an imaginary number, we used the conjugate of the denominator to rationalize. We're going to do the same thing. Would you agree the conjugate of this is square root of 5 plus square root of 2, right? Okay, so that's what we're going to use. So square root of 5 plus square root of 2 on top, square root of 5 plus square root of 2 on the bottom. In the numerator, I can go ahead and distribute, but you can also distribute in a later step, so I'm just going to leave it for now and I'll distribute in a minute. So 3 square roots of 2 times the square root of 5 plus the square root of 2. Just leave it alone for a minute. Go down here and I'm going to FOIL. So square root of 5 times square root of 5 is the square root of 25. Would you agree the outer square root of 5 times square root of 2 is plus square root of 10? My inners, negative square root of 2 times square root of 5 is minus square root of 10. And my last, negative square root of 2 times positive square root of 2 gives me minus the square root of 4. Now go to that denominator and you'll notice your inners and your outers cancel each other. Square root of 25 is 5. Square root of 4 is 2. So all you have in your denominator is 5 minus 2, which is 3. And now it will make sense why I didn't distribute in the numerator. So this is 3 square roots of 2 times the square root of 5 plus the square root of 2 all over 3. And this 3 and this 3 cancel, and you can go ahead and you can distribute that square root of 2. And when you distribute, would you agree, you get square root of 10 plus the square root of 4, right? And square root of 4 is 2. So your final answer is 2 plus the square root of 10. All right, let's take a look at the very last example, and we're going to do the same thing. We are going to use the conjugate of the denominator to rationalize. So that's going to be 3 plus the square root of 6 over 3 plus the square root of 6. Just write the numerator as distribution for now, and let's see what happens. So 4x times 3 plus the square root of 6, we'll just leave it like that. Foil the denominator, and I've got to make a little squiggly line here so no one gets confused between what goes with what problem. 3 times 3 gives us 9. My outers is going to be plus 3 square roots of 6. My inners is minus 3 square roots of 6. And my last square root of 6 times square root of 6 is going to be minus square root of 36. All right, the inners and the outers are going to cancel, and the square root of 36 is 6. All right, so in my denominator, I have 9 minus 6. Notice it got rid of all my square roots. 9 minus 6 is going to give us 3. So I have 4x times 3 plus the square root of 6 over 3. And I'm going to be honest, not compelled to distribute that because it's not going to help me simplify anything if I do. So if you do distribute, that's fine, but it is not necessary.